logical reasoning tips and tricks. We're in series. There are kinds of series. Number series, and you have also alphabet series. But in number series patterns, once you have identified the pattern, apply it to the number before or after the missing number in the series to get the desired answer. In number series patterns, first is to consider is the prime numbers. Given numbers are series of prime numbers 11, 13, 17, 19. We will start from 1 because prime numbers multiply, it's a multiple of themselves and 1. So 1 times 1, 5. 3 times 1. No other numbers that will multiply, only the number itself and 1. So 3 times 1, 5 times 3, 5 times 1, number 5 and only it's 1 and 1. 7 times 1. So 8 cannot be because there is 8 times 1 and 4 times 2. So therefore the 8 is not a prime number. So 11 times 1, 13 times 1, 17 times 1, 19 times 1. Those are the prime numbers. Squares and cubes. Next pattern is the squares and cubes of numbers. So the numbers are series of perfect square or cube roots. Example, square root of 9 is 81. Square root of 10 is 100. Square root of 11 is 121. Square root of 12 or 12 raised to the power of 2 is 144. 13 raised to the power of 2, it's 169. How about the 1 raised to the power of 2? Still 1. 2 raised to the power of 2, 4. 3 raised to the power of 2, 3 raised to the power of 2, it's 9. 4 raised to the power of 2, it's 16. 5 raised to the power of 2, it's 25. And 6 raised to the power of 2, that is 36. How about for cube root? Cube of number, it's multiplying in the base. Example, 4 raised to the power of 3. Your 4 is the base and your 3 is the exponent. The same here, wherein your 9 is your base and your 2 is the exponent. So therefore here, 4 raised to the power of 3 multiply 4 3 times. So therefore 4 times 4, 16 times 4, 64. 5 raised to the power of 3. 5 times 5 equals 25 times 5, it's 125. That's it. Patterns in differences. Calculate the differences between the numbers given in the series. So, example, 2, 5, 8, 11, 14. Here, the difference between the numbers is 3. The difference between 2 and 5 is 3. 5 and 8, it's 3. So, hence, the next number will be 17. Geometric geometric series. When each successive number in the series is obtained by multiplying or dividing the previous number by a fixed number. So, geometric series is involving of multiplying or dividing the previous number by a fixed number. Example, 5. The different 5 in order to obtain 5 it's to multiply 5 with 9. So 9 times 5 will give you 45. Okay. For 45 multiply it with 9 will give us 405. Okay, 45 times 9 will give us 405. The same also, 405 divided multiply it by 9 will give us 3645. The fixed number here is 9, and multiply it to the previous number to get the succeeding number. Next, odd one out. Odd one out. When all but one number is part of a series, for example 5, 10, 12, 15, 20. Here, all numbers except 12 are multiples of 5. Okay? Multiples of 5. Add 1 out. So, when all but one number is part of a series, add 1 out. So, therefore, your 5, 10, 12. So, the next will be 15, 20, then the next will be 13. It will continue the odd because we started with 12 and then it will continue with 5. Next, n raised to the power of 2 minus 1 series. That is the series, that's the formula. N squared minus 1. So in which example 0, let's start with 3. 3 squared. 3 squared. So multiply 3 twice. So 3 times 3, 9. Minus 1, 8. How about? Okay. 3 times 3 is 9. Minus 1, it's 8. Okay. Next, how about n squared plus 1 series? N squared plus 1 series. So here, it's the opposite of n squared minus 1. N squared minus 1. Here, it's plus 1. Example, 2. 2 raised to the power of 2 will give us 4 because we will multiply the base, which is 2, twice. So 2 times 2, 4, minus plus 1, 5. Okay, that's it. Next, the middle digit is the sum of other two digits. The middle digit is the sum of two other digits. The middle digit is the sum of two other digits. So, example, 165. Our middle digit here is 6. And if you will plus 1 and 5, it will give us 6. 1 plus 5 will give us 6. 121. 1 plus 1 will give us 2. The middle digit is the sum of the other two digits. That's for number of series. Number series patterns. Prime numbers, squares and cubes of numbers, patterns in differences, wherein we will subtract the difference between numbers in the series. Geometric sequence, multiplying the previous number with a fixed number to obtain the succeeding number. Odd one out, wherein series, there is a series of pattern but there is an odd or different. Like here, 5, 10, 12, so 15, 20. So the series here is a multiples of 5 but there is an odd of 12. And n squared minus 1 series and also n squared plus 1 series. Let's go with alphabet series.